करेंगे काम, समझ गए। सबको ये बता देना है कि भाई परफॉर्मेंस बेस्ड जो है सैलरी वाइज होगी, सैलरी भी मिलेगा और बोनस मिलेगा, ऐसा परफॉर्मेंस।
Yes, you can see the board. You can see what I have presented. Just check and tell me. Can you see? Please tell me
Yes,
if you can
sir.
proceed. Something else? No.
Yes, sir.
Yeah. Yeah. Good. Okay. So let's start. Now today we'll be doing, as you know, that is ray optics. Okay. So already 15 minutes are gone, so I will not waste time. Directly let's start with the topics. So in the ray optics board point of view, what things you should know? First thing comes mirror equation, which you have done in 10th also. All of you know this mirror equation. Then lens maker formula, right? Agree or not? Lens maker formula. All of you know about this lens maker formula. Next, what we have? Next we have focus. Okay, or I'll say combination of focus. Combination of, I'll say like this, right? Next, what else we have? We have refraction that comes with prism, right? Refraction, prism, and also we have total internal reflection. Total internal reflection, right? And what else? Optical instrument. What is that? Optical instrument. Now, looking at the previous year papers and the importance of this chapter, we know that this chapter carries how many? 6 marks. Okay. Out of the 6 marks, this will be divided into three part. 3 marks, 2 marks, and 1 mark. 1 mark will be direct question, expression, or a simple equation. Okay, or can be a simple problem also. All right. Now, 3 marks is going to be derivation. Now, remaining 2 marks will be problem or a small derivation. Okay, this can even come for option, by the way. Okay, looking at the pattern, this can even come for the option. Someone has sent some message. No. Okay. So, board exam is something now we don't have to study hard. We have to study smart. To always plan, strategy, and then study. Okay. Just not. It's not like you start your take your book and start mugging up. Don't do that. All right. So how you have to start? Let's see. So this ray optics got this 3 marks derivation. Now, which other derivations can be asked in the exam? First, that is lens maker formula. All right. Second, that is my check here. That is my prism. Or it can be also asked as total internal reflection and its application. When I say total internal reflection, I'll be doing this. Okay, it's a derivation. All the derivation I'll be doing for you all, and also I'll be telling you what are the
Sir,
application of total internal
please
reflection. Yes,
repeat
tell me.
again. Sir, please repeat again.
Okay, I'll repeat again. Fine. So what I said in the board exam, the as per the looking at the pattern in previous year papers, the importance of this chapter is such a way that 3 marks one derivation is coming, 2 marks ka one problem is coming, and 1 mark ka one problem is coming. Now the derivation can be asked from the following topics in this chapter. Topics are either it can be from lens maker formula, right? Lens maker formula we have, right? Refraction at the surfaces of lens. All right, that we have. Then we have second big derivation, that is prism. Okay, that is prism. Third, we have total internal reflection, or its application, or both can be asked. Done. And last we have optical instrument. Optical instrument meaning simple microscope, compound microscope, telescope, and all this. And problems, these 2 marks problems can be asked on power of lenses or lens maker formula equation, or can be asked on Snell's law also. All right, everything is, these are the important topics which you have to complete. So today I think we should be able to complete all these topics. So tell me if you don't understand anything. Okay, I'll be going, and we know that we don't have much as I can. Okay, so listen carefully. Fine, let's start. So okay, so first we'll start with, that is my prism. Why I'm doing this prism? Because prism is very important. Okay, now I'll be doing prism, lens maker formula, also the optical instrument, everything. Don't worry. Now, before doing this prism, we should know what is reflection and what is refraction. Reflection is like a, let's see. Say this is a mirror. A mirror, the difference between a mirror and lens, I'll explain you. First, understand a mirror is something which one side is shiny. Say this side is shiny and this side is blocked, like what we use in home, right? We can see our face. What happens in this type of mirror? We can see our face clearly. Say example, whatever size is your face, same size you can say in the mirror, right? You can see the mirror the same size because the mirror is straight. So the object what we see, or the image what we see, that is exactly like ours. That is not inverted. It is what? It is erect. It is virtual, right? It's a proper one. Then we have different other types of mirrors. Say example, if I bend this particular mirror in this way, okay, if I bend it in this way, that this is my block surface, and shiny surface is here, outer part. Then this kind of mirror is called as, anyone can tell me? That is called as convex, right? Convex. Okay. And if you notice here, this is called as my plane mirror, because straight, right? What we use at home, there is a plane mirror. And third mirror can be of this type. Say example, if I block this side and my shiny surface is this way, inside curve, then this becomes my concave mirror. Clear na? I hope you have cleared this. You have understood, right? Now, next, coming to the lens part. So what we see here, the rays which are coming and striking at the surface of plane mirror or convex mirror or concave mirror are called as reflection, or reflection of rays. Understood? That is called F. There is a F in this, reflection, right? Now if I give a same example, but if I change my case in the sense, if I take one mirror this way, this is a mirror, and I take another mirror, right? Do you understand what I'm doing? I'm taking one mirror, another mirror. Now I'm combining, I'm merging both the mirrors. Okay. So in this case, combination of these two mirror becomes my lens. So lens is nothing but they're the combination of two mirrors. Clear? Understood? So in this lens, what will happen? Okay, in this lens, what will happen? The rays which are coming now and striking on this, they will not get reflect because there is no blocked area. See, the place which is blocked now, it is already replaced by another mirror. So nothing is blocked here. So this rays will pass through this mirror and the lens. Okay, I can say, even say combination of mirrors, or I can say lens. Now I'll use the word lens. I hope it is clear. So the ray will come here, it will strike and it will get bend. What will happen? The ray will get bend. Why it is bending? Because outside is what? Outside it is all air. But inside this mirror or this lens is called my, what is that? Glass medium. Understood? It is a glass medium. Medium meaning where my rays are traveling. In air, when the rays is traveling, that will be straight like this. But the moment it will be going inside my lens, it will bend. And this bending of rays are called as refraction. Where we don't have F, we have refraction. Okay, yeah. See the difference, huh? There is something called reflection, and this is my refraction. Okay, refraction meaning the rays are going inside the medium or inside the lens, passing inside, and reflection meaning bounces back. Simple as that. Now, a prism is in the terms like this. It's a triangular structure, okay, where if you see in 2D it is triangular, okay. Say name is A, B, C. Clear? Now, say my object is here, or you can say a rays is passed. A ray of light is passed from here. It will go like this. It will go like this, and will strike here. Right. The moment it will strike, it will bend because what? It is prism is a glass. It's like a glass, so it will bend inside, and the bend in such a way that it will be parallel to the BC surface. Understood? It will be the parallel to my base BC, and at the moment it will come here, it will again bend. Why? Because see, first it was in air. First it was traveling in air. Now at this point it is turning in glass medium. So it is going into the glass medium. So it's bending. Now it's traveling in the glass medium, and after this point it is coming back again in air. So again it will. What will happen? Again it will. Someone has sent a message. Yeah, Shubham Narvekar. Reflection means deflection. Yes, we can say like that. Okay, deflecting. Okay, bouncing back. Okay, yeah, you can say. Okay. Now, say my ray, some ray, you can name the ray as X, Y, Z. You can just name anything. So this ray of light is going starting at this. It will getting bent. Now again, when it is coming out in air medium, again it is bending. So you can see two times. So what we take, say there is a mirror here. Okay, and we always draw a normal. Normal is always perpendicular to it. Okay, like this. So here also what I'll do, I will draw two perpendiculars. Let's see which ones. In case of prism, we'll draw two perpendicular. First one from here. Check. Huh? I will take some other color. Huh? Red color. So say there is a this perpendicular distance, right? And this is also perpendicular. Say okay. So there is a perpendicular. Properly, I'll draw here. So this perpendicular will what will happen? I'll just draw properly. Check. I hope it is clear. So it will meet. See, yeah, where it will meet. It will meet somewhere here. Agree? Right. So this is my 90-degree here, which you don't have to write. It is by default understood that this is my 90-degree. This is also my 90-degree. Fine. Okay. Now let's name. So this point is say example my X, and this point is say example my Y. Fine. And this point is my O. This fine, na? Now, what we take, say example, this black ray which is coming first, this ray. If this ray which is coming, if say it was not refracted, then where it will travel? It will travel straight like this. Yes or no? Check. It will travel like this. Now it should travel like this, but it's bending. Similarly, just back trace this one, this ray. So it will be like this. Yes, just back trace it. Now let's see what things are happening here. Now, whenever we say that there is a reflection or refraction, the angle between the normal and the ray which is coming is called as angle of incidence. And here, the refraction, or you can say this part, okay, the refracted ray and this perpendicular. Can you see this? Which is the perpendicular line? Understand, huh? This red color. Can you see this red color? This is a perpendicular line, right? So the angle between this refracted ray and this perpendicular is called my refraction, angle of refraction. I'll name it as R. This is my R or R1. I think I have drawn the figure very small. I'll just erase and I'll draw properly a bigger one so that you can understand better. Okay.
So it is also not called as theta.
Sorry. Ask again. I'll draw it again. Hold on. This is my base, my A, B, C. So a ray of light will come, it will get parallel and it will come out here. I'll tell you what are these angles are called as. Okay, this also I'll tell you. Just a second. Okay. Now, this is my tracing back, right? Then I have a normal. Okay. Now I'll name it. Let's name it. So this is my point X. This is my point X. This is my point Y. All right. This is my point, say example. This is my O. And this point where it is meeting, I will call it as, tell me something, say M. Right. Now let's see the angles. What I said, the difference, the angle between this perpendicular, which is a perpendicular, this red line. Okay, this red line is a perpendicular to the surface. The difference between this perpendicular ray and this ray, incident ray. Okay, this is called an incident, now, which is coming, is called as angle of incidence. And then this black color ray, can you see this black color ray which is coming? It is getting what? Inside it is getting refracted. So the angle made by this refracted and this red perpendicular, this part is called as refraction angle, angle of refraction. I'll say R1. Yeah, there is another refraction here. Check. This is my R2. Right. Now this ray is coming out. This black color ray is coming out. Since it is coming out, the angle again, this is also red line, here also red is perpendicular, right? So the angle between this perpendicular and this coming out ray is called as angle of emergent. Why we call angle of emergent? Because this is coming out, emergent. We say no, like something is emerging from water, something is coming up. This is also coming out, right? That's why we call it the angle of emergent. And the main which is the aim of the derivation, it's a derivation, right? That is here, it is hidden here. Check, this is that part which is called angle of deviation. What is called angle of deviation? That is del. So what is our aim in this prism? So basically we want to find out what is our angle of deviation value and how it varies. Now, why we need to do this? Because a prism has one function. Actually, there are two functions. But first function, everyone must be knowing, that is dispersion of light. It, what it does, whatever the white light is coming, what it will do? Can someone tell me? It will, what a prism does? Come on. It splits into its component colors, 7 colors rainbow, what we know, right? A white light gets split into its component, all the colors, 7 colors. That's the function of prism, right? What it does. And second is that a prism bends a light or a ray of light in 2 degrees. That is either 90 degree or 180 degree. This is the second function of a prism. So it bends the light in 2 degrees. That is either 90 degree or 180 degree. Right. So we have to see this particular thing only. Right. So we will find what is our deviation angle. Let's see. So I'll start with derivation. All of you be with me. Okay. Let's start. So first I'll start. I will assume there is a, can you see this quadrilateral? Tell me, all of you can see this A. See, I'm naming A, then X, then O, then Y, and again A. Can I see this quadrilateral? Quadrilateral A, then X, O, and Y. Possible? Yes, na? Now I know that what is the sum of my, can you tell me what is the sum of all the angles in a quadrilateral? what will be the sum of all the angles in the quadrilateral? Come on. Angle sum 360. Yes or no? You forgot all these things. School standard. Now, we also know that here these angles, which angles? See this normal. This is my normal, say N1, and this is my N2. Right? Angle 1 and angle 2. Someone sent some message. Okay. Now, this is my N1 and N2. Whenever I'm saying normal, refer to this N2 and this is my N1. So for N1, look at it. The N1 is the ray which is perpendicular to the surface. So what will be angle here? Angle between the surface and this. The X angle will be by 90 degree, perpendicular, right? So angle X is 90. And what about angle Y? That is also 90. Because the normal is always perpendicular to the surface. So I'm already having my angle X and angle Y as 90 and 90. That is 180, right? So total angle should be, angle in a quadrilateral should be angle A plus angle X plus angle Y plus angle, what is that? O, should be equal to 360. Out of which I know my X and Y are how much? They are 180. So I'll directly replace my angle X plus angle Y as 180. Right? Let's see. So I will write it as angle A plus 180 plus angle O. I hope it is understood, right? That means my angle A plus angle O is equal to what? 180 I can say another side will become minus because there is 360 here. So my angle A plus angle O will be equal to what? 360 minus 180. Answer is 180, right? Check. Till now is fine. All clear? See, this is important. 3 marks or 4 marks of derivation. So please understand. So my angle A plus angle O is how much? 180, right? Next. Now refer this. Now tell me one thing. What is this O? Look at the triangle. Which triangle I'm talking about? The down triangle. Okay, I'll again mark it as blue. So see this triangle. One, this line. Second, this line. And third, this line. Can you see this triangle? Now, what is the angle sum property? The sum of all these angles in a triangle is how many? What is the angle total sum? 180, right? So I can say, which are the angles by the way? R1 plus R2 plus this angle O, right? So I'm having my R1 plus R2 plus angle O equal to how much? 180. Agree? Fine. That means my angle O, now look here, my angle O can be written as 180 minus angle R1 minus angle R2. Fine. And angle O I'm writing as 180 minus R1. See, a minus I'm taking outside, meaning a minus will come out, it will become plus inside. Check. Open the bracket and you can see. See, don't misunderstand this angle I am writing directly R1 plus R2 because by default we are only doing in terms of angles, so it is understood that they are angles only. Fine.
Sir, you will send this
So,
PDF on group.
you want this PDF on group? Fine, I'll send this PDF on the group. Okay. Now listen carefully. So my angle O is equal to 180 minus R1 plus R2, right? Can I replace this angle O in my previous statement? Check here. Angle O is here, circled. I'll just replace my angle O is equal to 180 minus R1 plus R2 in my previous statement, that is here. So this statement, I'll rewrite it. Okay, I'm rewriting this statement as, what is that? Look here, 180 plus angle O, right? 180 plus angle O. But angle O is what my? That is plus 180 minus, what is that? Correct, 180 minus R1 plus R2. Agree? Yes? Or look at this one. This will become complex. Let's take this equation. This is simpler, na? Only two terms are there. So angle A plus angle O is equal to 180. I'll write it again. Angle A plus angle O equal to 180. I'm replacing my angle O as this. So it will become angle A plus 180 minus R1 plus R2 equal to 180. Now this is also plus 180, this is also plus 180, cancel, right? And this is minus. I'm sending this bracket, entire bracket, to my right hand side. So it will become angle A equal to R1 plus R2. Simple. Check. So till now what I have done? First I drew the figure, right? Then I am taking my quadrilateral, that is A, X, O, Y, A. Alright. Clear? And then after taking that, I am finding my equation, that is angle A plus angle O is equal to 180. I'm getting easily, right? Next, I'm taking this blue triangle which is down. Okay? And I'm using my angle sum property. I'm writing in terms of this. Okay? So I'll write it as equation 1. Alright. Next. Now let's consider the up triangle. Can you see this triangle? Up one, this red one. I'll draw with red color because there is nothing with red color, na? So see this triangle. This, and this. That is my MXY. So let's do that. So in triangle, what was that? That was MXY. I'll write MXY. Now, this is something you have to understand, okay? And I want you to understand here itself. See this PDF I can share in the group, but what I'm doing it, I'm trying to erase also here. So you may not understand. So better you write. Okay, whatever I'm writing now, better you write. So it's pointless sending in the group. Because some will be saying like for the first time. Those who want, they please message me personally. I will mail you or I can send you on WhatsApp. But not in the group. Because it's not properly. Right? Because I'm erasing also. So you'll get confused yourself. So better you ask me. I'll send you personally. Those who have joined. Now, what we can do is
Okay, sir.
take this triangle, the red triangle. We know that 8th standard there was something called exterior angle property, something like this, right? I'll draw a bigger one. Say if I'm having a triangle and I'm having this angle. So this angle, which is exterior of the triangle, is always equal to sum of this angle and this angle, right? Not this, not this angle. Sum of other two angles, always. So now use the same logic here. Check. This del is the outside, na? Outside angle. That means the del is equal to what? Which two angles? This angle plus this angle. Agree? Simple. But the problem is we don't know this angle. Check. This is my 1. This is my 2. But we don't know what are these angles. Do we know? No, we don't. How to find out? Simple. Let's see this one. Consider, can you see this angle? Angle I. Can you see this angle? And these are the line which is corresponding exactly opposite to this eye. So tell me now, if this is one, this is my eye, then what about this entire angle? This entire angle will be also eye. Why? Vertically opposite angles. If this one is eye, then this entire will be also eye. Agree or not? Yes. So this is also my eye. So I want but only this one. But I don't see, entire is my eye, but I don't want my entire. I want only my small angle, this angle. How to find this angle? It will be entire angle, that is my angle I, minus this small angle, which I don't want. That is my R1. Agree? So I minus R1. Done? Understood? Now, similarly, my this second angle will be what? Same way. If this is my total is E, then entire will be my also E. So it will be, this angle will be what? E minus my R2, right? Small angle. So second angle will be what? E minus R2. Now what we have to do? Exterior angle property says that this angle, exterior angle, is the sum of 1 plus 2. Now this is my one angle, this is my second angle. Addition of both is my del, that is my deviation. So I'll write my angle of deviation is equal to sum of, that is I minus R1, okay, plus I minus R2. Now, sorry, E minus R2 it is. Okay. That is my E minus R2. Check. Now let's combine na. I'll combine plus E I'll take like this. And here now this is minus R1, this is minus R2. I can take minus outside common. So the moment I take my minus outside common, what I'll remain? I'll remain R1 plus R2. Simple. Now, have you seen something like this? What is my R1 plus R2? Check where you have seen. Somewhere? Check here. What is my R1 plus R2? Angle A. So that I'll write where? Here. So it will become I plus E minus A. That is my del. Yes or no? Check. So simple. Yes. I hope it is clear. Now, done. So till now what you have done? Now we can just think in your brain what things we have done. First we drew the prism diagram, right? All the marking and all. After that we took a quadrilateral. Then in that we used the angle sum property, that is 360. And we got the equation 1, remember that? Then we took a down triangle, right? Then we took this down triangle. Okay, then we took this down triangle. And from here we got that. From this down triangle what we got? Check. We got this equation. Yes. And using this both the equations, that is quadrilateral and the triangle, we found my angle. What I found out? I found this angle A is equal to R1 plus R2. Simple as that. Perfect. Now, after that what we did? We took the up triangle. So there are two triangles, na? Check here. One is this blue triangle, one is my red triangle. The blue triangle is already used. Now, red triangle I am using to find my angle of deviation. Okay, that also I found. Now, since I have found my angle of deviation, now next step is what? Let's see. Okay, next step is assumption. Next step is assumption. We say that for minimum deviation, or say if you want a minimum deviation, my del will become my dm. Dm meaning minimum deviation. My del is the maximum deviation, and this is my dm is my minimum deviation. Remember this, huh? Understood, na? For minimum deviation, we can say, see, understand, na? If this deviation, this blue angle, this angle of deviation, this part is my minimum, that means my line will lie exactly on this. So in that case, I can say my angle I and angle E both will be same, and angle R and this angle R2, that is R1 plus R1 and R2, both will be same. So simple assumption that if my del is equal to del minimum, that is my deviation is equal to minimum deviation, I will have my I equal to E and R1 is equal to R2. Right? Understood? And if R1 is equal to R2, then what I can say, they can be equal to what? If R1 equal to R2, they can be equal to simple R, because they both are same, na? Values are same. So we will substitute here. Let's see, huh? So I'll write where exactly you have to substitute. See, I'm writing this equation 1. Can you see this equation 1? I'm writing it again. And this is my equation 2. That also I'm writing again. So both I'll write. First equation 1, that was angle A equal to R1 plus R2. And I'm writing my second one, that is my angle of deviation is equal to, that is my I plus E minus A. Right, these two equations. Now for minimum deviation, what we have? We have R1 is equal to R2 is equal to R, and I is equal to E. Can you see this? Simple. See, I don't know if I'm going fast, because many people they joined just now. Not many, 2 people. So if you are not understanding the previous part, you can ask me what exactly I did. Okay? Those who are there, they will understand. And if anyone has an issue, they can definitely tell me to go slow. I will go slow. Okay? Hello? Should I go slow? Or pace is fine? You understanding? Pace is fine, or should I go slow? Tell me fast. Okay, someone texted. Okay, understanding good. Okay. Okay. Some are joining now. Okay, next. So I am taking my assumption. So if I take my assumption that that is my R1 equal to R2 equal to R. So this equation will become, my angle A will become R1 and R2, they are same and they are equal to R. It will become R plus R, that is 2R, right? So my angle A is equal to 2 times R. That implies my R is equal to angle A by 2. Right? I have got my R. Right? And same thing, what will happen to my this? Now I am taking minimum deviation, right? My del will become, with this del will become minimum deviation, that is dm is equal to, I said na, my in the second assumption, that is I is equal to E. So I can write this E as I. So I can write I plus I minus A. This implies, okay, this is equal to 2I minus A, right? Because I plus I is what? 2I. So I can say that dm equal to 2I minus A. I will send this minus A that side. It will become positive A. So dm plus A, right? And this 2 is multiplied here. So if I send it this side, it will become division is equal to I. So now let's see what we have. We have expression in terms of I and we have expression in terms of R. Simple. I'm having my I and I'm having my R. So next, if I have my I and I have my R, what to do here? I will use Snell's law. So I'll use my Snell's law. That says sine I by sine R equal to n to 1. Fine. So what is my I, by the way? Just now I found out what is my I. Let's check. I is dm plus A by 2. And what is my R? A by 2. So I'll write it down. So my sine, now for small angle, what we take? See, we are taking small deviation now. If you take small deviation, the angles will become simple. That will be very, very small. So my sine and sine I can just remove. What I'll have? I'll have I upon R equal to n to 1. That implies I is what? That is my dm plus A by 2 upon, what is my R? R was A by 2. That is equal to n to 1. So 2 to cancel. What remains? I will be remain with dm plus A divided by A. Now split. How do you split? Like this, na? A plus B by C. Then what we do? We write A by C plus B by C. The denominator we take common. So here also we can do the similarly. So I can say dm by A plus A by A will be 1, right? Which is equal to n to 1, which is equal to n to 1. Understood? So next step I'll write now. Can you notice this? 1 is addition, right? If I send right hand side, it will become minus. So I'll write it as dm. Anything else is there with dm? Yes, there is something else with dm. Check. dm by A is there, na? So dm by A equal to n to 1 minus 1. Now dm, send this A that side. It will become multiplication. So A into n to 1 minus 1. So this is the proper 3 or 4 marks for derivation. Okay. Simple. I hope it is clear. Chalo. So next I am starting with optical instrument, that is simple microscope. Fine. See, remaining things are also there, but then since the time is limited, I want to do the questions which are most probable to come. And I think this year a prism or optical instrument ka one of it will be coming for 3 or 4 marks. It can be 3 or 4 marks. Okay. So let's start optical instrument. So optical instrument starts from microscope. Right? Microscope. That is, say example, simple microscope. Let's start with the simple microscope. So the simple microscope operates very uniquely. Let's see. Say I'm having this one principal axis. Okay. I will draw one lens. I'll keep one lens here. Check. I've kept one lens. Now there is an object here, which is, say example, is kept at infinity. Okay. It's kept at infinity. Now the object, what will happen? A ray will travel like this. And from here it will get refracted. Agree? a ray will come here, and from it will get refracted. Yes, from where it will refract? Exactly at the focus. Agree? Right? And another ray will pass from here that will not get refracted. Now, why I'm saying this? Listen to me very carefully. Three sentences. Sentence number one, you can say these are formulas, kind of formulas. Whenever you have your object at focus, okay, whenever your object is at focus, image will be at infinity in case of lens. If your object is at infinity, the image will be at focus, right? And no rays will be refracted, meaning no rays will bend if your rays are passing through center of curvature, meaning if there is a ray passing from here, it will not get refracted. Understood? It will not bend. So my diagram is not proper. I'll just draw it again. Give me a second. Yeah. Here. So this is my object. Ray is going. It is getting refracted here. And one will pass directly from here. I'm not able to draw properly. Something like this. You see, it's not bending, huh? Diagram is like that. Now, we know that these rays cannot meet this side. Can they meet this side? No, no ways. They are going apart. So we'll have to trace it back. To trace it back, let's trace it back. Trace, trace, trace. Check. We have reached here. Fine. Clear? Now, the moment it has reached here, the object has here. Check. Can we see that this was the object and we have got a magnified image here? Because simple microscope, what is the function of microscope? It magnifies, right? Okay. So, I can say this is my AB. If say this is my AB, height of the object, then this will be my A dash, B dash. Understood? That is my height of the image. Now, from image to the center of curvature, my distance is given by D. Why D? That is called distinct vision. What is that? Distinct vision, meaning that is a minimum distance we can see the image. Understood? And from this object to my center is called as, everyone must be knowing, that is U. Okay. Fine. My focus is somewhere here. No, my focus, remember, focus was somewhere here. Fine, not till now. So if you notice, we are having here some angles formed. Angle number one, that is this one. This is the angle, right? So I can say if this is the angle, check, this angle is for which triangles? One triangle is here, my black color triangle, check. And one triangle is here, that is my red, blue triangle I'll draw. Can I see this? Okay, one is black triangle, one is blue triangle. So in the black triangle, what I can say, I have my height of the, what is that? Height of the object. And I also know this one, right? That is my adjacent. I do not know what is my hypotenuse, right? This is the hypotenuse now because 90 degrees here. So I don't even have to worry. I don't have to take. So which trigonometry will be dealing in terms of, if this is the angle, na, then angle ka, this becomes my opposite and this becomes my adjacent. So which trigonometry ratio deals with opposite and adjacent? That is 10. So tan of theta, okay, is equal to, what is that? Tan of theta is equal to, anyone? Tan of theta is equal to opposite by adjacent. Opposite in my, what is my opposite? Height of the object, that is AB, upon, what is my adjacent? That is my, say, B, and this is, say, O. So it is my BO or OB. Fine. I've got one thing. Agree? And also now see the blue triangle. Now, something to note that for both the triangles, my angle is only one, same angle. So I can say another tan theta is equal to, now this time I'm taking the blue triangle. So for the blue triangle, what is my opposite side? Check. For this theta, that is my a dash b dash, this one, right? So it is my a dash b dash upon which distance? This distance, that is my o b dash. O b dash. Now both are 10 theta and 10 theta. That means this should be also same, na? This and this I can equate it. So I will equate my AB upon DO is equal to A dash B dash upon OB dash. Right? Now, what I'll do now, I know that magnification is given by height of image upon height of object. Can you see this is AB here and this is my A dash B dash here. So I'm taking my AB to the denominator, cross multiplication, and I'm taking this OB dash to my numerator, this side, interchange. So it will become A dash B dash upon AB equal to OB dash upon BO. Simple as that. Yes. Now this is my magnification. Agree? So magnification is equal to, what is my OB dash? That was D. And what was my BO? U. Both were negative. Check na. OB dash. This is my OB dash. And this is my OB. Both are left hand side of the lens. That's why they are negative. And negative will become positive. So it is becoming how much? D by U. Fine. Is it clear? Understood, na? But we are not done here. There is a second part of this. Okay. So we have got total how many formulas? One magnification is here. Second magnification is here. Right. Now, we know the lens maker formula that says 1 by f equal to 1 by v minus 1 by u. Agree? All of you. So I can say my 1 by f equal to, see, 1 by, now v is my d, na? In this case, my v, image distance is what? D, but it is left side of the lens, just now we saw. So minus d. And minus u is also my left side, so it is also minus u. So this will get cancelled. Done? Simple. Okay, I hope this is clear. And next, check, this is my d by u, right? This is my d by u. So what I'll do now, I will multiply throughout by d. So I'll multiply here also by d, I'll multiply here also by d, and I'll multiply here also by d. Agree? This minus minus became plus. So I can just rewrite properly. That is d by f equal to, now d and d cancel. What remains? Minus 1. So minus 1, right, plus d by u. Now I am sending my minus 1 to left hand side. So it will become d by u, that this d by u is equal to my d by f plus 1.